In our last video, we discussed about fluid. In this video, we will learn about different classifications of the fluid and important principles behind those classifications. Fluids can be classified in different ways. The most common criteria are viscosity, density change, phase, Newton's law of viscosity. Based on viscosity, fluids are classified as ideal fluid or real fluid. Ideal fluid is also termed as imaginary fluid. Based on change of density during a unit operation, the fluid can be classified as incompressible or compressible. Based on phase, the fluid can be classified as gas or liquid. This is the most common classification that we use in our daily life. Based on Newton's law of viscosity, fluid can be classified as Newtonian or non-Newtonian fluids. Let us understand each classification in detail. To understand the fluid classifications, it is important to learn the difference between normal force and shear force. A normal force acts perpendicular on the fluid and tends to reduce the volume of the fluid. That is, it compresses the fluid. It happens in case of pump, compressor, blower, etc. A shear force acts tangentially on the fluid and tends to deform the fluid, and in this case density remains the same. Let us visualize the normal force and shear force. This is a body of fluid. A normal force acts like this, and a tangential force or shear force acts like this. We have understood the difference between shear and normal force. Now we can easily understand fluid classifications. An ideal fluid is a fluid in which there is no layer-to-layer interaction, and layers can move independent of other layers. That is, if a shear force is applied on one layer, then only that layer will move, as you can see. On the contrary, real fluid is one in which there is layer-to-layer interaction. This internal interaction is called viscosity. Based on viscosity, the real fluid is also termed as viscid fluid, and ideal fluid is also termed as inviscid fluid. In real fluid, if a shear force is applied on one layer, then viscosity transmits the effect of the force to the other layers and a velocity profile is developed. We shall discuss further under Newton's law of viscosity this scenario. Let us we have a fluid of mass m and volume v1. It experiences a force such that its volume is reduced to v2 for the same mass. Hence the density will be increased. If this increase in density is 5% or more, then fluid will be termed as compressible fluid. Both liquid and gases exhibit this behavior. Liquid in case of high pressure pumping and gases through compression. Again, let us have a fluid of mass m and volume v1. It experiences a force such that volume remains constant. In such circumstances, the fluid will be termed as incompressible fluid. Both liquid and gases exhibit this behavior. Liquids in case of low to moderate pressure applications, and gas during passing through a fan, like in our home. But generally, gases exhibit compressible fluid behavior and liquids as incompressible fluid. Newton's law of viscosity is an important basis to classify real fluids. Let us have an amount of fluid and a shear force acts on it. As a result, a velocity profile will be generated as in front of you. Under these circumstances, Newton's law of viscosity states that tau is equal to mu into du over dy. Here tau is shear stress, which is basically shear force per unit area, and du over dy is shear rate. Mu is viscosity. A fluid that follows this linear relationship between shear stress and shear rate is called Newtonian fluid. For example, water. A fluid which does not obey this linear relationship is called non-Newtonian fluid, such as shown by the curves. In our daily life, Fluids like honey, jelly are the non-Newtonian